All right, ladies and gentlemen, we're going to start in with chapter 11 for matrix algebra. Okay. So hopefully you can see this. Again, this is new. I don't think you guys do this in Algebra 2, but I could be wrong. I don't remember. All right, so it says we got 5 goals for today. Oh my gosh. Goal number 1, we're going to find the sum and difference of 2 matrices. We're going to do those by hand. That's going to be super easy. Goal number 2, we're going to talk about scalar multiplication of matrices. Again, super easy. Number 3, find the product of 2 matrices. Again, I'll show you how to do that by hand, but from here on out, I'll also show you how to use your calculator. Goal number 4, it's pretty much just use your calculator, find the inverse. And 5, solve a system using inverse matrices. Again, I'll pretty much show you how to do that by your calculator. It'd be easy, okay? So guys, this is what a matrix looks like right here, okay? All it is a way for us to organize a bunch of data, okay? In these little boxes, we use these brackets. We call those matrices, okay? Now, distinguish these different matrices, as we take a look at these matrices, to distinguish which is which, we should know about rows and columns, okay? So we got rows and we got columns. Rows is what we got side to side. Columns are what go up and down, okay? And does anybody know what structure this is in Chicago? What is that?
Soldier Field.
It is Soldier Field. The spaceship landed on old Soldier Field, and we still have the columns out in front. If you can see those columns, some of you guys have houses in front of your house that have these big old pillars or columns. So columns, I'm trying to give you guys a visual here of my beloved, who are not very good, and they're out of the playoffs, but out in front, we got these columns going up and down, okay? So when we talk about the size of a matrix, we talk about how many rows and how many columns. So for example 1, you can't mess this one up. This has 2 rows and 2 columns. This is a 2 by 2. Okay, this is also known as a perfect square matrix. If I look at example 2, we call this a column matrix because it has 1 column. It has 3 rows and 1 column. Okay. And the last one is what? What size is this one? Is it a 2 by 3 or a 3 by 2?
2 by 3.
Oh boy, Gavin, 2 by 3. It has 2 rows and 3 columns. Okay. In a little bit, I'll show you how you can use your calculator just to remind yourself, is it the up and downs by sides, or is it side by side by up and down? Okay. So I'll show you how to do that in Calc. All right. So example 4 and 5 says you can add or subtract matrices of the same side. If they are not the same side, then the answer is no solution. You can't do it. Okay. All right. Any ideas, any suggestions on how we add matrices together? Take a guess. It's super easy. Any ideas? No ideas. All we got to do, guys, is take the corresponding elements and add them together. So this is an element, okay? This is in the first row, first column. I match it up with the first row, first column element, and I just add it together. So 4 plus 3 is 7. And then I do it again. I take the first row, second column element and add it to the first row, second column element. So I just say corresponding elements, add them or subtract them. All right, so 2 and 7, that gives you 9. So if I do the next one, in red, I've got -3 plus a -2. That's -5. And last but not least, I've got 9 and 4. 9 plus 4, 13. Okay. Put a little bracket around that. So again, when we're adding and subtracting, all we're doing is we're basically adding, subtracting corresponding elements. All right, so subtraction. You could go through and do the exact same thing. I got 5 minus 1 is 4, and go through that. The other thing I like to do is I like to add the opposite. So I'll make this a plus, and then I'll change every sign. That way I don't forget to do the subtraction. Okay, you don't have to do that. Just for me, I like to do that. Okay, so 6 minus 6 is 0. Negative 1 plus 2 we know is 1. We got 3 minus 4 is negative 1. We got 7 minus 0 is still 7. And last but not least, we got negative 9 plus 3 is negative 6. All right, so adding and subtracting, super duper easy. Just make sure if you're subtracting, either add the opposites like I did, or go through and make sure you subtract each and every single one. Okay. All right, so goal number 1, find the sum and difference of two matrices. Super easy. Okay. All right, next. So this is something that we do to do shorthand. Okay, it says you can multiply matrices by a constant. This is called a scalar multiplication. When we do this, they'll say take 3 times matrix A. They use capital letters. Okay, so up here are our matrices: matrix A, matrix B, and matrix C. Okay, so when it says 3A like this, that's just 3 times matrix A. Matrix A up there is 3, 7, negative 2, and 4. Okay? So when you're doing scalar multiplication, all you're doing is you're taking this 3 times everything. Okay? Basically distribute to every single element. So 3 times 3 we know is 9, 21 for 7 times 3. 3 times negative 2 is negative 6, and 3 times 4 is 12. All right. So goal number 2, scalar multiplication with matrices, super easy. All you're doing is distributing. Okay. Really don't need your calculator for this unless you can't add, subtract, multiply, or divide. Okay. All right. Any questions, y'all? Backside. Moving right along. Okay. So here we go. It says you can multiply. So we're moving on to the next goal, is multiplication of matrices. You can multiply matrices when the number of columns of the first matrix and the number of rows in the second matrix match. Okay, so we're trying to multiply these matrices together. Sometimes you can do it and sometimes you can't. It's based on this premise. You can multiply when the number of columns in the first matrix match up with the number of rows in the second. So here's the idea. I'm going to take matrix A times matrix B. Okay, so remember when we look at the sides, we look at rows and columns. And we're going to take that times another matrix, which again, size-wise is always rows by columns. Okay. So it says you can multiply when the number of the columns in the first matrix and the rows of the second matrix match. When you put the sizes next to each other, okay, these two have to be the same. If those are the same, then we can do it. If those are not the same, then we can't. Okay? And then your final answer is going to be these, your size of your matrix is going to be this guy. Okay, so let's put this into action. I've got my 3 matrices here. Matrix A, we agree, is a 2 by 2. And matrix B, rows by columns. This has 2 rows and 1 column. So this is a 2 by 1. And C is a 2 by 2. Can't mess that one up. Okay. So the first question is, can I do A times B? So I put the sizes next to each other. A is a 2 by 2 and B is a 2 by 1. Can I do it? And the answer is, you betcha. So these have to be the same. So I can definitely do it. Now my answer, the size of my answer is going to be a 2 by 1 matrix. Okay? So it's going to be on the outsides is what my answer is going to be. So again, I'm going to show you how to do this by hand. And then after that, I'm going to show you how to use your calculator. And then from there, I don't care how you do it. You can use your calculator, you can use your mind and do it, whatever you want to do. All right, so I've got matrix A. Matrix A is a 2 by 2. It's 3, 7, negative 2, and 4. And then I'm taking that times matrix B, which is 3, 2. So far, so good. I know I can do it because the columns in the first match up with the rows of the second, and my answer is going to be a 2 by 1. Okay, it's going to have 2 rows and 1 column. Okay, so I just put blanks here. So this is 2 rows, 1 column. Okay, so how do you do it? All right, if I want the first row, first element matrix, then I'm going to take the first row, first column to get the first row, first column element. Okay, so this is what I do. I take 3 times 3 and I add it to the next product, 7 times 2. So 3 times 3 is 9, 7 times 2 is 14, and I add them together and I get 23. So I'm taking these numbers here, multiply them to these numbers here, and add them together. Okay, I'm going to do it again. I want the second row, first column element for my answer matrix. So I take the second row numbers times the first column. I take negative 2 times 3. That's negative 6. And then I take 4 times this 2. And I add them together. 4 times 2 is 8. So negative 6 plus 8 is 2. Final answer, I get a 2 by 1 matrix, 23, 2. So again, I know the size of it based on the outside numbers of the sizes. Row times column, add those numbers together. That gives me 23. If I want this second row, first column, I take the second row times the first column numbers, add them together, and I get my number. Okay? All right, so that's how you do it by hand, right? Well, how do I make that a little easier? Imagine this was a 2 by 2 times a 2 by 2. Or imagine this was a 2 by 2 times a 2 by 10. Oh my God, you'd have to do that a ton of times there. Okay, I don't want to do it a million times. I want to just punch it in my calculator and be done. Okay, so do you guys see the math menu? Underneath math menu, and this is where you guys put the Netflix away. Pay attention. Get your calculator out. I can tell some of you guys are sitting there watching Cobra Kai right now. Oh my gosh. Good Morning America. Turn it off. All right. You see underneath math menu, it says matrix. Okay, that's the menu I'm working in. Okay. So I'm going to press second inverse. X to the negative 1 is the inverse. Okay, I'm going to do second matrix. Okay. You guys all there? So second matrix. So underneath the math menu. I have a bunch of matrices all labeled A through I and even further. I'm going to go over to edit and I'm going to edit matrix A. We know the size of this guy, and this is where if you're not sure if this is a 2 by 3 or a 3 by 2, you can type in the numbers. So I know matrix A is a 2 enter matrix, 2 by 2. Okay, and then I'm going to type in my numbers. 3, enter, 7, enter, -2, enter, 4, enter. So I double check, I've got a 2 by 2 matrix. Matrix A is 3, 7, -2, and 4. So I'll walk you through that again because a lot of you guys have never used this before. So I press second matrix, second inverse right here, guys. Right next to the math menu, just underneath of it. Okay, so second matrix takes me to my matrix menu. I go over to edit and I do matrix A, 2, enter, 2, enter. 3, enter, 7, enter, -2, press enter, 4, press enter. Okay. Well, I want to type all these guys in. So I'm going to do this again. I'm going to do matrix B. Okay. So I'm going to go second matrix. I'm going to go over to edit, go down to B. If you edit A, then you just erased everything you just did in A. I want to put in B and C now. Okay. So B, press enter. Matrix B is 2, enter, 1, enter. It's a 2 by 1. Okay, and this is where if you're not sure, is this a 2 by 1 or a 1 by 2? That's definitely not what that looks like. So I know it's a 2 by 1. I type in my numbers, 3, enter, 2, enter. So I've got matrix B now. It's a 2 by 1. If I'm going too fast, let me know. If you're lost, let me know. Matrix C. So I go second, matrix, edit, go down to C now. Matrix C is a 2 by 2. 4, enter, -7, enter, -1, enter, and 2, enter. Okay. Before I leave the screen, I always double check. Okay. Because from time to time, you will punch things in wrong, and we got to fix that. Okay. If you make a mistake in this window, then you make a mistake everywhere. Okay. Even just a little negative sign. Okay. And guys, it happens to me a lot. The good Lord has blessed me with some big old fat fingers. I try to press 3 and all of a sudden I'm pressing 2. All right, so watch out. I really blame my dad. He's got fat fingers too. All right, let's do this, huh? So we go to our home screen. So we go press second, quit, clear anything out that you got. Okay. And I only want to type in AB just like this. Okay. So I go second matrix, number 1 is A. So I got A, press enter. And if you want to put a multiplication symbol in, you can, but if you just go right away and have A next to B, that's multiplication. So I'm going to go second matrix, go down to number 2, B, press enter, does it all for you. It just took A times B. Okay, so I'll walk you through that again. Okay, I'm in my home screen. I'm pressing second matrix. Don't go to edit. I already got it edited. I want number 1. Second matrix, go down to B, press enter. 23.2 is my final answer. Okay. All right. Let me know if you got questions. Use your microphone. You're not getting what I'm getting. Let me know. All right. So the next question, example 8 says, hey, take B times C. Take this 2 by 1. Okay. And then multiply it by this 2 by 2. Can you do it? Look at the columns of the first, rows of the second. Can you do it? No way. That's a no solution. Can't do it. Okay. If I try to take the numbers here times these numbers here, they don't match up. There's only one number for this row and there's 2 numbers for this column. So it doesn't match up. You can't do it. Okay. If I was not writing down the numbers and I'm just being a robot and not looking, well, I go second matrix B, just so you can see what happens in the calc. Second matrix C. So I go BC, press enter, and you get a dimension mismatch. The dimensions don't match up, that means you can't do it. Okay. All right, some other things you should be able to do. If you ever want to do scalar multiplication, you don't know what to do for scalar multiplication. Maybe I want to do 3 times matrix A. So I can go 3A like this. And basically, again, all is it doing is it's multiplying 3 times all those numbers, just like we did on the first example, or example 6, I guess it was. Okay. If I want to take matrix A and add it to matrix B, I can do that. I got second matrix A plus second matrix B, C. Let's do C because we can't do A and B together. So if I want to take these two matrices here and add them together, they're the same sizes. I can do that. Okay. 3 plus 4 is 7. Negative 7 and 7 is 0. That's negative 3, and that's 6. Okay, so you guys can use your calculator to do scalar multiplication and addition and subtraction. All right, all right. Do you guys have any questions? No questions. All right, next, we got to talk about the identity of multiplication, and then we can talk about the identity of a matrix. Okay, so as we go through real quick, basic numbers, right? The identity of multiplication. Three times a number will give you 3. What's that number? 3 times any number gives you 3. What does that number have to be? 1, right? That's also known as the identity of multiplication, okay? If I multiply that number, it gives it back myself, okay? So there has to be identities for matrices, and those identities are always square matrices, okay? And so they're 2 by 2s, 3 by 3s, 4 by 4s, so they're square matrices. And everything has zeros except for the diagonals going from left to right down. So all the diagonals, okay? All right, so if you ever want to find those identity matrices, if I go second matrix and go to the math, okay? And you guys see identity down here, number 5. So if I want to do 2, okay? If I go second matrix, over to the math menu, and I'm in matrix, identity 3. That gives you the 3 by 3. Okay. And now if I take this matrix, and let's make this 2 again. If I take this matrix identity 2, and I multiply it by A, second matrix A, it gives me the exact same matrix. Okay. So this matrix times any 2 by 2 matrix will give it back itself, or any 2 by 1 or 2 by whatever. Okay. So that's called the identity. Am I going to quiz or test you on that? No, but should know what identity matrix is. Okay. Well, an inverse, so that's identity. Let me write that. So now the next question is, well, what's an inverse? So it's best to explain what inverse is of multiplication so you understand what it is for matrices. 3 times the number gives me 1, or the identity. Well, what's that number? What is that number? So 3 times the number equals 1. That number has to be what, guys? Use your microphones. Solve for X. Solve for the hashtag. 3 times a number equals 1, so that number has to be what? 1.
0.3 repeating.
1 over 3, right? 1/3, right? I divide over the 3. This is called the inverse of multiplication, so very good. Another way to write that is 3 to the negative 1 power. Okay? So when we're talking about matrices, okay, when we're talking about inverses of matrices, we have to do A inverse. Okay? So A times A inverse or A inverse times A will give me the identity. Same thing happens with regular multiplication. If I take 3 times its inverse, I will get 1. Okay? So, example, how do you do that in the calculator? Okay? So I've got C up there. I've got 4, -7, -1. Let me rewrite that. So I got 4, 7, -1, and 2. Well, now I want to do the inverse of C. So how do I do that? I got C already in my calculator. So I got second matrix. I go down to number 3. There's C. Inverse button is the same button that we've been pressing for matrix. Do you see X with a little -1 there? Power. So I press that on top of the C. Okay? And that is the inverse of matrix C. I press enter, and it gives me 2, 7, 1, and 4. Okay? Now, if I take that times matrix C, just so you can verify, if I take C times its inverse, I get the identity. Okay? Which should make sense. That's the same idea here. If I take 3 times 1/3, I get 1. Okay? Now, this is how you do it by hand for a 2x2. Okay? I'm not going to show you that because you all should have calculators. There's no reason to do that by hand. Okay? All right. Last but not least, ladies and gentlemen, solving systems of equations. Okay? So what we have here is we have A, X, and B. We have a variety of matrices. And do you remember how hard it was to solve this guy? Right? Example 10. Now I'm going to show you how to do it like lightning fast, super duper fast. Okay? So I'll explain how to do that. Okay? First off, we have matrix A is what we call the coefficient matrix. So I take a look at all my coefficients, the numbers in front of X and Y, and I make a matrix of it. In this case, I've got 2, 2, I've got 4 elements. I have 3, -1 for 3x and -1y, and then I have -2 and 1. Then I have matrix X up here, okay? So times matrix X. Matrix X is my variable matrix. Matrix X is just a 2x1 column, X and Y. Okay? The reason why this works with multiplication, rows times columns. If I take this row times this column, I get 3x minus y. And if I got this row times this column, I get -2x plus y. Okay, that's why that works. And then I have matrix B. That's my constant matrix. Constants are the numbers without x's and y's. In this case, I got 8 and 4. Okay? So these are my matrices that I'm going to be using. Okay? Well, this says if I have AX equals B. So let me write that again. This says if I take the inverse times A, okay, if I multiply it to this side, I got to multiply it to this side. Okay? And A inverse times itself times A reduces down to I, the identity matrix. And the identity times anything is what you have. You get x. So identity times x, like 1 times x is x. Okay? When you do the inverse of A inverse to one side, you got to do it to that other side. And order matters. Notice I put it on the left-hand side of A. I've got to put it on the left-hand side of B. Okay? Because when we multiply, order matters. If you didn't get anything out of that, just understand this big concept here. If I want to solve for my x and y, I got to use this guy right here. So if I want to solve for x and y here, my variables, then I got to do A inverse B. Okay, so if I want to solve this guy by hand, I could, substitution elimination. If I want to use my calculator, now I can use my matrices to do it. I'm going to do matrix A is 3, -1, 2, -2, and 1. I'm going to do the inverse of that guy, and then times matrix B, which is 8 and 4. So let's do that. All right, it goes second matrix, edit, matrix A. Matrix A is a 2 by 2. I have 3, enter, -1, enter, -2, enter, and 1, enter. Oh, looks like I typed it all wrong. So let's try it again. 3, enter, -1, enter, -2, enter, 1, enter. Okay, so I always double check. This is matrix A. It's a 2 by 2. I got 3, -1, -2, and 1. Now I'm going to go and edit B. So I got second matrix, edit, go to matrix B. Matrix B is a 2 by 1. 8, enter, 4, enter. I go to my home screen. This is what I'm typing in now. This guy right here. If I want to solve for x and y, I'm going to do A inverse B. So second matrix, A, inverse, second matrix B. So I'm typing in A inverse B, I press enter, does it all for me. Okay, so I get matrix X is 12, 28. So I know X is 12 and Y is 28. If you want to write that as a coordinate point, you can. You can leave it. You're doing it in my class. You could just leave it in a system like that. Well, matrix like that would be totally fine. All right, so before you get out of here, okay, do you remember how long this took us yesterday? It took us like, I don't know, 5-8 minutes to do this problem. Example 10. Well, now it's going to take you less than a minute if you know how to punch in calculators, okay? So I'm going to, show a little work. I'm going to throw in matrix A are all my coefficients. So I just go down 1, -1, 1. My next set of coefficients I've got are 2, 3, and -1. And the last one I've got is 3, -2, and -9. Matrix B is all my constants. I've got 8, -2, and 9. And now if I want to solve this thing super fast without having to do any elimination or substitution, I'm going to do A inverse B. So I grab my calculator, go to second matrix. I'm going to edit matrix A. This is a 3 by 3 now. 1, enter. -1, enter, 1, enter. 2, enter. 3, enter. -1, enter. 3, enter, -2, and -9. So always double check. If I make a mistake in here, I'm not gonna get it right. So I gotta check it. 1, -1, 1. 2, oh, you dirty dog, Mr. Gotch, you got a 6 in there. How did that happen? I told you, I got fat fingers. You gotta watch out. So I got matrix A good, and I'm going to go to matrix B. So second matrix, edit. I want to go down to number 2, matrix B, press enter. Matrix B is a 3 by 1. I got 8, enter, -2, enter, and 9, enter. The nice thing is, if you have an 84, you can go ahead and just copy and paste this guy. Go up there, press enter, does it all for you. If you have an 83, you got to probably type it in. Second matrix, number 1 is A. Inverse is the same button we've been pressing, that little X, so -1 power, that's inverse. And then second matrix, B. Okay, so final answer I get is 4, -3, and 1. And again, that represents X, Y, and Z. If you want to write that as a coordinate point, you can. That's where these two planes are intersected. I would be okay with this. You guys see what my math lab wants. Okay. All right, ladies and gentlemen, that is it. I've shown you everything I know about matrices. Okay.